Okay, so let me start sharing my screen. I'm going to try to remind you about what we talked about last class. We started talking about arrays, and let's see here. We talked about arrays. We learned what are they, how do they work, and then after that, we talked about how for loops are associated with loops, with arrays in general. What are indexes, and how do we have access to those indexes, and how do we use them to have access to the elements of the array? We talked about the for each loop, and we said what's the difference between it and between a regular array for loop. And then after that, we learned about how do we create an array and initialize it at the same time. We learned about some methods associated with arrays, for example, the length. And then after that, we talked about how do we compare arrays and how do we assign arrays. We didn't talk about compare, we just talked about assignment of the arrays. And how do we assign an array to an array? What is the shallow copy? What is a deep copy? And then we learned how do we do deep copy by ourselves or by using different methods like the one that you see here and the one you see here. Okay, so today we're going to continue with arrays, and we're going to learn about the first and one of the most important operations when it comes to arrays, and that operation is searching for an array. And now, to search for an array, again, it's very, very, very basic and one of the essentials operations that we perform on arrays, because when you have a collection of data, you're probably going to be looking for an element in that collection of data. And in those examples that we're talking about right now, for example, if you have a list, or sorry, an array of 10 values, integer values, searching for a value simply implies that you are going to be looking for the position and the index of that element in that array. But that the search operation doesn't stop at that point, because you may have an array of objects, like, for example, students, and you want to have access to the data of a student. And you have a very, very big array of those objects, and simply searching for an object in an array, it's a little bit more complicated, of course, than searching just for an element, but we can search for students in an array of students objects based on their ID numbers. And your whole point here is not only that you want to know where's the location of that student, because having access to the location may not provide you with any piece of information that you may need, but most importantly, you want to have access to the information related to that student in that array. For example, I have an array for the 7 or 8 students that I have in this classroom, and I want to have access to a certain specific student in that group. So what do? I search for that student by his ID number, and once I have access to his location index, after that I can have access to his name, his address, and all the other relative information. So that's why searching is very, very important. Now, whether you're searching for an integer in an array or you're searching for an ID for objects in an array, the process is very simple, and it goes like that. I'm going to start by creating a variable. We'll call it index, and I'm going to set index to -1. Okay, that's very, very important to understand. Assigning an index to -1, I'm doing that for a reason, and I'm going to talk about that in a sec. And after that, to be able to search for an element, we simply go and scan the array. So let me just go up and see which array that I have here. Let's go with array 1. Array 1, so I will come here, and let me just show you another thing. If I come here and say integer s equal array 1, and I think I call it my array 1 dot length semicolon, it will be much more efficient to do it this way, comparing to integer I equals 0, I is less than s, and s here is for the size, and then I plus plus. Now, what I want to say here is that I can come here and use array 1 length in this instead of s, and the program will work with no issues. But I said creating a variable and storing the length in it is going to be more efficient, because if you put my array1.length here, that implies that every time you want to compare I with your length, you're going to have to calculate and you have to call the method that will give you the length back. So that's, again, will just be a repeated operation that you may really don't need it. So that's why it's recommended to start by creating a variable to store the size of it. Now, here's what we're going to do. We are simply going to compare. Oh, I forgot. We're searching for an element in this array. So let's say my integer that I'm looking for, let's say val. Let's put it as val1 or val. Let's keep it val. Let's say I'm looking for the value of 3. Now, let me just double check and see. Do we have 3 here? We do have 3 here. And then after that, I will put, let's say, 31. So I'm searching for 3. Here's what we do. We are simply going to check if every item in my array, so if val equal my array 1 of I, that simply, again, means that I am going to compare the value that I'm looking for with every value you have in that array, with every item that you have in the array. And if they match, if you find a match, you're going to take an action. If you don't see a match, you're going to continue and you're going to continue and you're going to continue. Now, what's going to happen if you find a match? You have to do 2 operations. The first one, you have to update the index to equal I, which represent the index or of the value that was found out. So in this case, I is simply located at index of 0, 1, 2. So we are going to change the value of index to equal 2. This is where we found 3. And then after that, we break. Break simply means I found it. There's no need for me to continue searching for that item. Now, with that been done, we could come here and say if index double equal -1, I'm just going to come here and say system.out.print line. And I'm just going to come here and say show a message, and I will say the value is not found. Okay, so the value that we're looking for is not found. Else, let me just copy this. The value which was actually found. I'll just put it here. The value is found, or was found. Let's put it was at index, and we'll come here and put index. Okay, so let's go back here to why did we initialize the index with -1? Because we know the index value in general could be 0 all the way to the maximum value an integer can hold. So we need to assign a unique value to the index as an indication that the value that we're looking for wasn't found. So by searching for a value that doesn't exist in the array, I'm simply going to be going through all the items of that array, and this if statement will never become true. And because it will never become true, index value will never be updated. And because it will never be updated, the original value of index will always be kept as -1. Now, what I'm going to do, I am simply going to, now let's just run it. And you can see here, the value was found at index 2. Now let's look for 31. And if I run it, and the value was not found. Okay, now usually, let me just put it this way. Usually, whenever you want to search for an item, we have a method for that. So let me just go ahead and create a method for that in this area here. So public static integer, it's going to return an integer, and I will call it search. And what am I supposed to pass to the search? I can pass the following. I can pass an array of integers. We'll call it A. Integer value that I'm going to be searching for. And then after that, we're going to integer size. So I'm going to send those 3 values. Now, what I'm going to do, I'm simply going to copy those values here. You know what? I can calculate it here. There's no need for me to pass the size. So I'm going to start from this point all the way here. Copy this. And let's put it here, Control V. Now, instead of my array 1, we'll just pass it to be A and S here. So we'll put A again here. And I'm going to come here and create an index and set this to -1. Okay. And then after that, we'll just say return index. So if index was updated, it's going to return whatever the value that you have here. Otherwise, it will return -1. Now, what we need to do, we need to take all this out. And I need to cut this from here and put it here. Wait a minute, Control, Command X. Let's put it here. Now, instead of assigning index to -1, I am simply going to be calling the method itself, search, and let's just copy this and put it here, Control V. And now what we're going to be passing, we're going to be passing my array 1, and we're going to be passing val. So those two values are simply going to be assigned, going to be passed to the search method, and then the search method is going to return the index. And here, the index value -1 here. If the index was returned as -1, we're going to get this message. Otherwise, it's going to be get this one. I'm going to get the exact same value here. So item was not found. And here it is. Okay, so now what if, and let's just put it this way, I have a 3 here. Okay, so now I have 2 3s. This method that I have here simply will return the first appearance, because the moment it was found, it's going to stop the whole process. The question is, what if I want to return the last appearance of 3? If that's the case, then you just have to take the break away. And let me just, let me take that away. And now you'll notice when I'm going to pass 3 in this area here, it's not going to return this index. It's going to return this index here. So let's give this a try. And it's at index 8. Now, the question that you may ask, what if I want to have all the indexes? Well, if you want to do all the indexes, we have something we're going to cover next class. The next chapter is all about array lists. And I'm not sure, but if you're going to talk about array lists, you need to talk about vectors as well. So what I'm going to do, if the book that we're using is not going to talk about vectors, I'm going to include vectors there. But here in this area here, if we want to actually hold all the indexes, then we will need to have a very special data structures that we're going to cover in the next chapter. Okay. So this was the first operation that I wanted to talk about today, which is search operations. And then we're going to move on to the other operation in Java, with arrays in general, which is sorting an array. So what is sorting? Sorting simply means you rearrange the items of the array from the smallest value to the greatest values, or from the greatest value to the smallest value. That's simply what sorting is all about. Now, before I jump into the methods of sorting, we need to understand what is the point of sorting. Like, why would you want to sort an array to start with? Sorting arrays makes the search operations more efficient. And I'm going to give you an example that you use in your daily life, and then I'm going to tell you that we use that same exact example in arrays and data structures in general. So if I give you a list of names and those names are not sorted alphabetically, and I ask you to search for the name Adam. Now, Adam start with A, but because we know that the data or the array that we have is not sorted alphabetically, that simply means it could be at the beginning or it could be at the end. So you have to go and read all the elements in that array only to find Adam at the bottom, or you may not even find him, or if you're lucky, you will find him at the top. But here we're playing with chances. So if you have a data structure, array specifically, and you want to search for it, for any item in that array, searching in an array that is sorted will be much faster and more efficient than searching for an item in a data structure or an array that is not sorted. Now, in your next class, that you're going to take. It's called Data Structures and Algorithms. The first chapter you're going to be hit with and you're going to be dealing with, it's called the algorithm efficiency. And in the algorithm efficiency, you're going to learn how do you evaluate algorithms in general. And you're going to be talking later about searching algorithms and searching algorithms in sorted data. And you would notice that there is a huge improvement in the efficiency when you search in an array that is already sorted. So sorting is a process, or it's an operation that we would like to apply to arrays in this case, or data structures in general, to make the job of searching more efficient. Now that we know what is the whole point of sorting, you need to know that we have many different sorting algorithms. We have what we called a selection sort algorithm. We have a bubble sort algorithm. We have merge sort algorithm. We have quick sort algorithms, and we have selection and let me just try and remember what is the other one. Selection and insertion sort algorithms, and we have shell sort algorithms, and those are only the 5 or 6 that I remember at the top of my head, but in reality we have dozens of them. Okay, we have priority queues that could be used to sort data structures. Anyway, so we do have many different sort algorithms. Each one of those sort algorithms comes with, let's say, advantages and disadvantages. So usually, depending on how your data is normally distributed, you will be able to select the algorithm that will fit better. Some other algorithms will suffer from space efficiency. What does that simply mean? It simply means it's work fast, but it requires a lot of space for it to work. So if you are willing to give up space for speed, then that will be your choice. Some algorithms, no, it doesn't require any additional space, but it's a little bit slow compared to the other ones. So beside all this story, which again, when you're going to take the data structure class, you're going to be dealing with all of that, of course. In this chapter, in this class, we are only going to be dealing with one of those sort algorithms. And the sort algorithm that we're going to deal with is called a selection sort algorithm. So before I start writing the code of how does it work, it's a really good idea to understand the mechanism of this sort algorithm. And to do so, I'm just going to use the PowerPoint to explain the concept. And let me go share my PowerPoint. Okay, so here, don't look at the for loop, but let's just look at the array that we have here. The idea is very simple. You start with the first item in your array, and you make an assumption that this item is the smallest item in the array. So in this case, I'm going to assume that 5 is the smallest. Now, all these details are explained in the book. So if you want to get more details, you can go ahead and look at it. But here it is. So we're going to start with this. We're going to look at the first item we have in that array, and we're going to assume that that is the smallest value in that array. And what we're going to do, we are simply going to go and search all the other items in the array, looking for an item that is smaller than the one that we are assuming is smaller. And we're going to keep tracking on the index of that item. So for example here, 5 and 10, no, 5 is smaller, so no. 5 and -3, 3 is smaller, so yes, let's keep that index under consideration. Now 20 and -3, no, that's not the smallest. And then 2 and -3, no, that's the smallest. So now we know the smallest item is simply 3 at index 2. What do we do at that point? We simply swap the item at index 2 with the original item that we assumed is the smallest. So what are we going to end up with? We're going to end up with having -3 here and 5 here. What do we do next? We go to the next value, which is, again, in this case, 10 at index 1. At this point, I'm going to still assume that this value is the smallest. It's not the smallest. It's the second to the smallest, because we know that the smallest value is already located at the top here. So I'm going to assume that this is the smallest value, 10. And because I'm assuming 10 is the smallest value, I am going to continue searching for all the items that I have in the list, looking for the one that is smaller than 10. And in this case, 5 is not. Well, actually, 5 is. And because 5 is, now I'm going to assume that 5 is the smallest value comparing to 10. And then you go to 20. 20 comparing to 5, no. 2 comparing to 5, yes. So now my index, my pointer here, is going to be referencing index number 4, which hold the value of 2. And now I'm going to swap 10 and 2. I'm ending up having 2 here. Now we move on to the third value. I'm going to assume this is the smallest value. And as I'm going, I didn't find any value that is smaller than that. So nothing's going to change. It's going to be kept at itself. And we move to the fourth value, which is 20. And I go to the next value, which is 10. And then since 10 is the smallest and there's no other values, so we're going to do a swapping. And once you get to 20, the last item here, you don't have to continue. You're going to stop at that point. So this is, again, how selection sort algorithm simply works. Understanding those algorithms, if you look at the code directly, it's going to be very, very hard to understand what's going on there. So it's very, very important to have a really, really good idea about how does it work first before you jump into the code itself. So with that being said, how can we now sort the array that we have, that we created in our program? So let me just go ahead. And by the way, if you have any questions at any time, please let me know. So let's go back to Eclipse and let's see how can we do that. One thing you should know that this operation implies having nested loops. Because as you see, you take the first item, you search all the other items. You move to the second item, you search all the rest of the items. So that implies having 2 for loops. So what we're going to do, we are going to start with the for loop here. And we're going to have another for loop here. And this is something we have to understand. So for the first loop, the outer loop, we're going to go integer I equals 0. I is less, and I want you to pay attention to this, less than s minus 1. And of course, I didn't define s here, so I need to come here and say integer s equal my array 1 dot length, semicolon. And then after that, I will come here and say I plus plus. Now, this s minus 1 is very, very important. And there is a reason for that. Why am I doing s minus 1 instead of s? Because if I go back to the PowerPoint, the last item you're going to scan is the one before the end. So let's go back here to 20. Once I get to 20, I perform the swapping with a 10. I don't do anything after that because you got the last value at the end of that array and you're done. So there's no need for you to continue. So basically, by the time you get to this value, this is the final value that's going to be processed in your array. So that's why we have s minus 1. Oh, wait a minute. No, not this one. And here we go. So at this point, I need to start by my initialization. I'm going to create an integer. I will call it mini. And I will set my array of I to equal that mini. So I'm assuming now the first item that I have here is mini. And then after that, when I is going to increase by 1, I'm going to assume the next item is the mini. And I continue that way. Also, index, I will just call it with an X here, equal I. So I'm going to keep tracking on the index. Oh, you know, I can use I directly if I want to. But let's just keep, let's see here. No, actually, let's just set this to 0. I'm going to use I as an index, as an indication of who's the item that I am assuming is the smallest at this point. So I'm going to keep those values here. And let's see what's going to happen after that. In this second for loop, here's what we're going to do. We're going to say integer j equal I plus 1.
Professor?
Yes.
You're using my array 1 and my array.
Did I use? Yeah. the same array that we searched before, which is this one. Is that clear?
Is my array and my array 1 the same thing?
No, they're
because
different.
yeah,
Here,
down
this is my array that we created last time.
Yeah.
And this is my array 1, which is different.
I'm saying in the int min equals my array, you put my array instead of my array 1.
Oh, sorry, yes.
Yeah.
It has to be 1.
Okay.
Thank you. Okay, now this is J. J has to be I plus 1. Remember here, when you assume that the first item is the smallest, you start searching from the item next to it. So that's why the second search that we're going to start from the next item. And then J in this case will always be less than S. And then J plus plus. Now here's what we're going to do. This is very, very important. Our job at this point is to find out where is the index that hold a value that is smaller than mini. Okay, so mini will not change. I'll keep, let's see here. I know the value of I is pointing at the item that I'm currently working on. Actually, I don't need to have this one. I'll just put it as 0 as well. Those values are going to be updated. Or you know what? No, actually, I need to. Let's just put it that as, let me control Z that. I need it. My assumption here that mini is the smallest value. Because that may change as I'm going through the second loop. And index here is going to be 0. Here's what we're going to do. We're going to, as I said, compare each item and looking for the smallest one. So we're going to go here and say if, very, very important, if mini that I have here is greater, or let's go ahead and change it to my array 1 of J is less than mini. So I'm going through the items of my array, starting from J all the way to the end, and I'm asking myself, if I found an item that is smaller than mini, which again, the one that I assumed is the smallest value, immediately have to update mini to equal that item. And also, I have to keep track, where did that happen? So we're going to assign that to J. Okay. So this, again, let's just go down here. In this case, what am I doing? I'm assuming that mini is the smallest value, which is the item that I'm currently at. Let's say I of 0. I'm creating an index. I'm assigning it to 0. And I'm searching the rest of the items, the one that comes after I equals 0, looking for a value that is smaller. If I found a value that is smaller than mini will be updated to that value, and index will be holding that index for that location. If I found a value that is smaller than that new mini, update the new mini with the smallest value and update the index and continue. Now, after you are done scanning your array for the first time, you're going to have to check and see if the value of mini has been changed or not. So what do we do here? We come here and say an F. If my array 1 of I doesn't equal mini. Oh, wait a minute. Doesn't equal mini. What does that simply mean? Simply means like, oh, the value that I assumed at the beginning is the smallest value is not actually the smallest value, and there's a new one. Let's see here. We got a question in the chat. What is why 1 is subtracted from S? Okay, very, very good question. Let me finish this and I'll go back to that one. I'll explain the whole concept again, of course. So again, if as I'm going through this loop, I actually find maybe multiple times values that are smaller than the first one that I started with. Every time I find a new value, it's going to be updated and the index is going to be updated. So what I'm doing here, I'm checking if I actually, through the process of searching, I found smaller value, then all I have to do is to perform a swapping operation. Here's how we do swapping. Integer temp, and set integer temp to equal, very, very important, my original value of I. Control V, I. So This operation simply means I'm saving the first value in my array into temp. So I now have a space for temp. And now after that, I'm going to come here and say my array 1 simply is going to equal my array of index, index. So I switch. Now I have the smallest value is at its original place, and it's at the first place, that the place that we started with. And then after that, we go ahead and change array of index with whatever temp is. So let's go ahead here and put where is it? Temp. And here, for me to show you the results of what I'm doing here, I'm going to print the array with every iteration that I'm done. I'm going to print it before, and I'm going to print it after, and I'm going to hold the screen so you can see the change that's going on. Okay, for demonstration. So let me go back to the question. Why is 1 subtracted from S? Let me go back to the PowerPoint. Let me just make sure that I am not making any mistakes. I'm pretty sure I'm not making any mistakes. Yes. The reason why we subtract 1 from S for the outside loop, because by the time you get to the items before the end one, this will be the last item you're going to perform any operations. By the time you get to the last item, there's no values after that to perform anything. So for example, here, this is my original array. And when I got to 20, there was 1 value left for the swapping to perform. And by the time I'm done with the 20, which is 0, 1, 2, the fourth item, and by the time you get to the fifth item, you have no more data or anything to do with it. So there's no need for you to process this item because it's at the correct place. So I hope that was clear. So let me go back here. And here's what I'm going to do. I'm going to go ahead and use a for each to show you each. So let's go ahead here. This is at the beginning. It's going to print array 1 on the screen. And what I'm going to do, I'm going to use a print plus, and I'll put space, comma, plus. So you will see, and here I'm going to put a print line. Copy this, put it here, Control V, and I'll put a print line, and I'll take all this out. So this is simply going to show me the array at the beginning before I do the process, and this will show me the array at the end. So I'm going to copy this. With every single iteration, I'll be printing the arrays 2 times, before and after. So this probably will be repeated because if you're going to print this and you're going to go back here, it's going to be printed again. So I don't see a point. Well, yeah, here. It will make more sense if I cut this from here and put it here. No, actually, let's just print it. My bad. Let's just print it. So, and I need to have a screen holder. So do I have a scanner here? No, I don't. I don't want to create a scanner, but I have to. Scanner in P equal new scanner system dot in. Okay, let's import the scanner. And now let's go ahead. What I'm going to try to do here, I'm simply going to try to hold the screen. I will say in, what did I call it again? In P dot next line. Oh, next. This is again just to hold the screen. And what I'm going to do also is let me comment the whole thing here. And I'll comment this section. Of course, he's going to complain now about my array 1. So let me copy this. Put it here. Control V. Let me take this 3. I don't want to have any duplicated values, even though that should not be a problem. So here's the deal. The first type here is going to just do the search, which again, that's not a problem for us. This is what we care about. Remember here, this section that I put those 4 loops is just to show you and demonstrate the changes that are going to be applied. And I'm going to have this to be here as well, so I can actually see the results in each case. So let's go ahead and run this. Okay, so let's go back here. I want you to pay attention to this. This is my original array, and I do have 4 2 times. Let me just take out one of those 4s. Okay, let me just run it again. Let me put 2 here. And let me put a value here that is big, for example, 10. And here we go. Let me put 1 here. Now let's run it again. Let me explain what I just did. Here's my list of items. At the beginning, I'm going to assume that 10 is the smallest value. And what I'm going to do after I'm assuming that 10 is the smallest value, I'm going to compare 10 with all these values that I have here. Now, I found 4 is smaller than 10. So now 4 is the smallest value. 7 is not smaller than 4. 3 is smaller than 4. So now 3 is the smallest value. 11 is not smaller than 3. 12 is not smaller than 3. 1 is the smallest value. And now we compare 38. It's not smaller than 1. 97 is not smaller than 1. 99 is not smaller than 1. And 2 is not smaller than 1. And now I know that 1 is the smallest value. After that, I did here, and I came. Did the value of mini that I assumed at the beginning, I assumed that this is the mini. Did that value changed? That's what I'm checking here. Is the value mini is not the same as this one, which again, this one is 10 that I'm highlighting here, and mini is this one. So they're not the same, 2 different values. So what's going to happen here? Simply, I'm going to be swapping. I'm going to create a space called temp where I'm going to store 10 in it. So 10 is kept safe, and then 1 is going to be assigned to 10. So now what do I have? I have 1 here, and I have 1 here. But I need this to be 10, so that's what I'm doing here. I'm assigning 10 to array temp, and then now if I press enter, you will see 1 is going to be replaced by 10, and 10 is going to be replaced by 1. Oh, sorry, I have to print something. And look here, this is 1, and this is 10. So what's going to happen next? We're going to move on to this value. The reason why I'm having this screen holder here, I have to enter something, and I have to go with 1. So that's not a big deal. This is just for us to trace the change that's going on. So now I'm going to assume 4 is the smallest value. 7 is not. 3 is smaller than 4. So yes. 11 is not. 12 is not. 10 is not. 38 is not. 97 is not. 99 is not. 2 is smaller than 4. Sorry, 2 is smaller than 3. So 2 is the smallest value. And 2 doesn't equal 4. So I'm going to do the swapping operation. And then 2 is going to come here, and 4 is going to come here. And if I just press, for example, 1 and press enter, and you can see, oh, wait a minute. Why did that not happen? Oh, now it happened. Oh, yes, because I told you guys it's going to be printed 2 times. Now you can see we've got 2. Now I'm going to assume 7 is the smallest value. So 3 is smaller. Not 11, no. 12, no. 10, no. 38, no. 4, no. So 3 is 3 is still the smallest value. So 3 is going to be moved here, and 7 is going to be moved here. So press 1 again, and now you got 3 and 7. The reason why I'm seeing multiple times is because by the time I'm printing this, it's going to go back and print it again. So let's go ahead, continue. So what do we have next? We have 7. 7, and the smallest value here is going to be 4. So 4 and 7 are going to be swapped. So if I just go ahead and press 1 and press 1 again, and here we go. 4 and 7 are swapped. 11, let's look at 11. 11 and 10. So 11 and 10 are going to be swapped. Where is it? yeah, 11 and 10. Where is it? Here it is. This is 11. Or 7 was swapped here. And now with 7 was swapped with what? With 11. So 11 moved here. Yes. Now we move on to 12. We got 10, 34, 11, 12 will be swapped with 10. I think it will be much easier if I just take this one away. Control X and put it at the top. So you will see it. How does it change every time you move through the process? So I'm going to take this one away and let's just give it a try. A new run. So here we go. This is my original one. You can see 1 was replaced with 10. Now I have to press 1 and you can see now 2 was swapped with 4. And then after that, you'll see 7 is swapped with 3. And then 7 is going to be swapped with 4. And then 11 will be swapped with 10. Oh, sorry, not 7. I forgot we have 7 at the end. And now 12 is going to be swapped with 11. Where is it? 12 was 10. Sorry, not 11. And now we are at 12. 12 is going to be swapped with 11. 38 is going to be swapped with 12. 97 is going to be swapped with 38. And then 99 was going to be swapped with 97. And we're done. And this is how it works. So it looks like, again, it's a little bit longer. And by the way, this is one of the easiest sort algorithms. We have a lot of more complicated ones, especially those that are involve what they call it, recursion. And recursion as a technique, you guys are going to learn it in the upcoming class, the data structure class. Recursion, it's a little bit more complicated to trace comparing to this iteration, different type of method. So the idea here, we have an outside loop and we have an inside loop. And we are simply going to be assuming that the item that we are currently at is the smallest value. And we're going to search for a value within all the rest of the items in the array for a value that's smaller than it. If you're lucky to find one, then you're going to update the value mini to that value, and you can update the index value to whatever that smaller value was found. Then after that, you check. If you actually found a new smallest value, then you're going to do the swapping. If there is no value, then no swapping is going to be performed because your assumption was accurate. Is there any question about this part? Okay. I'm going to upload this file with the video, of course, later. Now, I showed you how do we create the method, or the mechanism of how do we do search algorithms. But the question is, you should ask, so am I coming up with something new nobody thought about before? The answer will be no. Sort algorithms are actually there and they're predefined and you can use them if you want to. And here's how it works. What I'm going to do, I'm going to create the same array that I have here. Let me copy it. And I'm going to just change the name of it. Let's call it array 2. Here's what we can do. This is very, very important. I can do the following. I can say arrays, though there is a predefined method to do that, sort and pass my array 2 and put semicolon here. Now you may ask, okay, why is he complaining here? Because you have to import the array class. And now if you go all the way to the top, Java util arrays has been imported. Now this will sort array 2. And again, remember, array 2 is an identical to array 1. So if I just copy this from here and put it here and just come here and put array 2 instead of array 1. And let me just take, let's see here. I'm going to take this one away. This is before, and this is After, let's see here. Where's the end of this for loop? Here's the end of this. Okay, yes. So I put it after. This is for array 1, and this here is going to be for array 2. Let's put an array before and after. This is array 2 again. So this is going to be before and this is going to be after. And you would notice that you'll get the exact same results. So this is array 1 before and after. This is array 2 before and after. So there is a predefined method to sort an array, and it's located inside a Java class called arrays, predefined Java class. And it's very simple. It's a static method. So type the name of the class, follow that with the word sort, and then you put the array that you want to sort. Now, if you want to sort the values, but instead of the smallest value to the greatest value, this is what you need to do. You need to include another parameter here, and that parameter is called collection dot reverse order, semicolon. Now, collection, well, what is that? There is double L here. Now, of course, just like how we have to import arrays, you have to import the collection class. And let's see here. Why is he not liking this? Remove the argument. Huh, that is weird. It should work for some reason, but it's not taking it. I tried it this morning and let me see. Why is it acting that way? This way again, I'm supposed to be able, here it is. I imported the collection. I'm supposed to be able to sort them from the greatest value to the smallest value, but it looks like sort algorithm doesn't like it. So here it is. The method sort is a type of array not clever with arguments. Okay, so I think it should be a different method. I'll double check on that and see why is it not accepting it. Okay, so let me take this out for now. I'll try to see why is it acting that way. Okay, so here we go. Those are the two methods that are very, very important that are associated with arrays that you need to know. And let me share my PowerPoint to see if we are missing any points. So this is the selection sort. And by the way, this part here that he's just telling you that this sorting algorithm could be applied to any object. But you need to create your own search algorithm when it comes to object, because you cannot search objects just like how you search primitive data types. Searching objects simply means you pass the objects in the array, but you have to use a key in those objects or a data member in those objects to use them in the comparison process. So you'll be able to sort the data based on that. So here we go. This is just, again, there's no class called sort. This is a class that he decided to create just for you not to get confused. And here's that sort class in this area. Two-dimension arrays. Two-dimension arrays is simply an array inside an array. And the best way to understand two-dimension arrays is thinking about tables, because in tables, what do we have? We have rows and we have columns. Same thing here with two-dimension arrays. We are going to have rows and we're going to have columns. So the question is, how do we create multi or two-dimension arrays? The idea is very simple. I'm going to go and show you that. Let me just make sure that for each we cover that topic. And that's it. Okay, so let's go ahead and look at the multi or two-dimension arrays. And let me use this area here. To create a single dimension array, for example, of a type integer, we create a square bracket and we call it, for example, table equal new integer and square bracket. And that's, again, how do we create a single dimension array? What are you complaining about here? Oh, the size. Let's say, for example, 3. Now, if I want to create a two-dimension arrays, all I have to do is to tell me 2 square brackets here and 2 square brackets here. And in this area here, you have to tell me how many rows and how many columns you will have in your array. So this table of this two-dimensional array will have 3 rows and it will have 5 columns. And that's how we create. Now, let's call this one table 1. Table 2, on the other hand, I'm going to create it in a different way. We'll go ahead and put table 2. Now, instead of us reserving the space using the keyword, I am simply going to use those curly braces. And in this case, I'm going to have 1, 2, 3, 4, 5. And in this area here, I'm going to have 6, 7, 8, 9, and 10. Now, can you tell me what is the size of this array? It's 2 by 5. 2 rows, 5 columns. Now, here's a thing, and this is acceptable in Java. Number of columns, they really don't have to be the same. You can see here, like the first row has 5 columns, the second row has 5 columns, the third row has only 2 columns. So in general, it's acceptable. Let's just put it that way. Doesn't mean that you have to put it that way, not necessary, but again, it's acceptable to organize a 2-dimensional array that way. So now that I have my 2 arrays here, this one is going to be initialized. This is going to be initialized to 0. How do I have access to those items? Well, here's how we have access to those items. Number 1, it's important to know how many rows you have and how many columns you have in an array. Now, with the assumption of every single row will have exactly the same number of columns, I can come here and say integer r equal, and look at this, table, for example, 2 dot length. This would tell me how many rows do I have. Okay, let's go ahead and try to figure out how many columns do we have. Integer c, and look what I'm going to do. I'm going to say table 2 of anyone, for example, 0 dot length that will tell me how many columns exist in the first row. And again, because I know every single row will have exactly the same number of columns, so I can assume that C is the number of columns for each row. Now that I have the number of rows and I have number of columns, and I'm using table 2 here as an example, here's how we have access to those items. 4, and I want you to pay attention to this, very, very important. Another 4. I'm going to come here and say for integer I in, equals 0, as long as I is less than R, which is the number of rows, I plus plus. And for the second one here, integer J equals 0, J is less than C, J plus plus. And now here I'm going to be printing, let's go ahead and use a system.out.print line or system.out.print. Now I want you to pay attention here. I'm trying to print them in a form of a table. So I'm going to come here and say table 1 look at this. Did I say table 1? No, table 2. I'm using table 2 here. Table 2 of I and J. So each item is going to be printed in that row, 1 by 1, with a space. Let's just put a space here. And after that, as you're done finishing printing the first row, before you start printing the second row, you need to go to the new line. So for that reason, right after I'm done with the inner loop, I'm going to go to the next line so I can go and move on with my table. Now look at this. This table has those 2 rows. Each row has 5 columns. If I run the program, you'll see that this is my table here. If I just come here and change this one to be 1 and this to be 1 and this to be 1, you will notice that I will get zeros. And here they are. Those are the zeros. So to have access to a 2-dimensional array, you simply need to know the location and the index of the row and the index of the column. Now, of course, if I want to have a 3-dimension, I can come here and say integer, and I'll say point equal new integer. And let's say, what are the spaces? Let's say we got 5 by 5 by 5. That's totally acceptable. It's a point in the space. So every single point will be described by its x, by its y, and by its z. And you will have every single point in this cubic space, spatial space, and you will have a value at that each point that you have in that 3-dimension array. And of course, you can have fourth, you can have fifth, you can have as much as you want. Okay, so this will, let me just stop sharing. This will be the end of this chapter. Next class, we are going to go through the project and the assignment, and probably I will bring with me a project from my own side. I'll try to answer that question in the classroom and while we're having this Zoom meeting, and we should be fine. So, are there any questions? Can you for each with 2-dimension?
And use it for each.
Oh
for
yeah,
each.
I was just thinking about that. But again, for each, if you use for each with the first row, that will give you what? Will give you the whole array. I'll say it might technically be possible, but I don't see the point of why would I do that.
Okay. Okay, thank you.
No problem.
Okay, bye.
Hey, you guys have a good day. And let me stop.
Thank you.